All right, so for examples 5 and 6, I would like you to use your calculator, and I'll try and show you on my calculator too. But what will happen on the exam is we'll give you, I know the specifically asking for the logarithmic model, so on the test we'll give you some data like you see in the table, but we will ask you to do the logarithmic model, we'll ask you to do a linear model, and we'll ask you to do an exponential model. And so what I want you to do is be able to write them down, what you see on the calculator, and then also the R values. So if you pull up your calculator, we're going to go into the stat mode here. So we hit stat. We want to go ahead and enter, or edit, excuse me, our lists. And so if you have something in L1 and L2, I'd like you to clear them out. And to clear your lists, you're going to go up to the top, hit clear, and enter, or come back down and do the same thing over here. So you can go up, hit clear, come back down. Be careful not to hit delete. That will delete the list. So I'm going to pause. I'm going to enter my X values in list 1 and my Y values in list 2. Okay, so you notice that I have entered the X's in list 1 and the Y's in list 2, and they match up. They both have 7 entries in each one. Now we can go back and we can do stat and slide over to calculate. Let's start with a linear regression, number 4. Go ahead and hit enter. So that's 0.36 for our A value. So maybe for linear, let's write down 0.36, maybe even the 3x, and the B value is 3.5, so plus 3.5, and this one has an R value of 0.96. The closer you are to 1 or -1, the better off you're going to be. So now let's go stat and calculate. If you scroll around the horn here, you can see some of the other ones, and there's 0 is the exponential regression, so let's go ahead and do that. So go ahead and say enter. And your A value is 3.8, so this one would be y equals 3.8, 1,3 times a B value of 1.057 to the x power. This one has an R value of 0.911. And then lastly, let's go ahead and look at stat, slide over to calculate. Here, go around again so you can see this part of it. Lots of students do the logistic model, but it's for logarithm, but don't let the LOG confuses students, and you sometimes choose that for logarithm, but we want the LN, which is the natural logarithm. So the natural log regression, number 9. Let's go ahead and hit 9, say yes, or hit enter. And here, let's write down y equals 1.071 plus the B value, let's just call it 3 ln of x. And here is the R, that's 0.999. So there's 6 of them there. So this is really close to 1. So right away I can tell that this is the line of best fit. And you can see in my graph below, I'm just going to go back now. We can make sure, second y equals, I have my number 1 stat plot on. So that's on. I'm using X list is L1 and Y list is L2. And if I go to a window, I want to be a little bit smaller than my X value. So my X's go 2 to 20, so I went 0 to 25. You don't need to be quite so big or as wide. And the Y's go from 3 to 10, so I went 0 to 15. So if you look at the graph, you can see that the data is curved. So the straight line would not make sense, because if the straight line goes through, you're going to probably end up somewhere here. And as you extrapolate or predict with this line, the data starts to curve away from it. So just to show you, if we go to y equals and we type in that 1.071 plus 3 ln of x, we'll see how close this line really fits, and it's almost perfect. And so that's another way to tell that that's a good line. Go ahead and put in number 6. Enter those things into your lists, and go ahead and find, again, maybe do a linear or exponential. If you have any questions, come and see us.